Thank you to watching Shoaib Views channel. This is the last part of steam turbine overhauling. In this part 1 explain the final inspection and reassembling of steam turbine. To assemble a steam turbine after a major overhaul, follow these steps. Preparation. Review the overhaul plan, ensuring all required parts and tools are available. Installation of components. Begin reinstalling components in the reverse order of disassembly. Use appropriate sealing compounds between joints to prevent leaks. Alignment. Carefully align the rotor and other moving parts to ensure proper operation. Final checks. Conduct thorough inspections of seals, bearings, and any critical components. Ensure all fasteners are torqued to specifications. Testing. After assembly, perform system tests to verify operational integrity before returning the turbine to service. It's important to double-check all procedures and standard operating protocols to ensure a successful assembly. A labyrinth seal inspection on a steam turbine involves visually examining the seal components, particularly the teeth and grooves, for signs of wear, damage, or excessive clearance. Visual inspection. Examining the seal teeth and grooves for wear, goring, or damage using a borescope or direct visual access when possible. Clearance measurement. Checking the gap between the stationary and rotating seal components to ensure it falls within the specified tolerance range. Alignment check. Assessing the alignment of the seal rings to prevent rubbing or uneven wear. Surface condition evaluation. Looking for signs of erosion, corrosion, or carbon deposits on the seal surfaces. Leakage detection. Checking for visible steam leaks around the seal area during operation, which can indicate excessive wear or misalignment. Thrust bearing inspection. A thrust bearing inspection in a steam turbine typically involves a visual examination of the bearing components for signs of wear, damage, or contamination, including checking for scoring, pitting, cracks, excessive wear on the thrust pads, and proper alignment of the bearing components, often accompanied by measurements of critical dimensions like clearance and axial displacement to assess the bearing's overall health and functionality. This inspection is usually performed during a scheduled turbine outage or major maintenance period. Inspection of blades in a steam turbine typically involves non-destructive testing and DT methods like visual inspection, dye-penetrant testing, ultrasonic testing, magnetic particle inspection, and sometimes X-ray radiography, to identify cracks, corrosion, wear, and other defects on the blade surface and root, usually performed while the turbine is partially disassembled to access critical areas, without fully removing the rotor from the machine. The focus is on inspecting the blade airfoil, leading edge, trailing edge, and the blade root attachment points, with special attention to high-stress area. A turbine turning gear inspection involves a thorough examination of the turning gear mechanism, which is used to slowly rotate a turbine rotor during shutdown or startup, checking for any signs of wear, damage, or malfunction in components like the motor, gear teeth, couplings, lubrication system, and associated instrumentation, to ensure safe and proper operation of the turbine during non-running periods. This typically includes visual checks, measurements of alignment and eccentricity, and verifying proper oil flow and pressure. Turbine Supervisory Instrumentation (TSI) is a system that monitors turbines for faults and failures. It provides real-time data to help operators and maintenance teams perform condition monitoring and predictive maintenance. The front standard in a steam turbine is a critical component that supports the various parts of the turbine and ensures their proper alignment and function. It plays a vital role in maintaining the integrity of turbine operations, and it is essential to ensure that all associated components are suitable for continued operation. In front standard there are speed pickup sensors, thrust sensor, axial movement sensor, key phaser and speed sensor and adjustment. It's speed sensed by magnetic pickups faced to the tooth, wheel 96 teeth installed on the rotor. As each teeth passes it generates pulse signal. Frequency signal from two pickups are converted into digital value proportional to turbine speed through frequency to digital converter. These are on right side. Other three sensor round tooth used for trip detector. These are on left side. A rupture disc, also known as a bursting disc, is a safety device that releases pressure when a system reaches a predetermined level. It works by rupturing at a specific pressure or vacuum, relieving pressure and protecting equipment and people. Rupture disc inspections are visual checks of the condition of rupture discs to ensure they are safe for use. Inspections should be performed at the intervals recommended by the manufacturer, or more frequently if necessary. A borescope is a tool used to inspect the internal components of a steam turbine. It's a flexible, or rigid optical device that allows technicians to see inside the turbine without having to disassemble it. Borescopes are used to inspect turbines for safety and maintenance reasons. They can help identify defects or imperfections. They can help prevent unnecessary maintenance, which can be costly for large turbines. Reassembling a steam turbine after major overhauling involves several critical steps. First, follow the manufacturer's specifications and tolerances closely to ensure proper assembly of the turbine components. This typically includes placing all parts in the correct sequence, making sure they align properly and fit together without gaps. When reassembling the casing, it's essential to use a proper sealing compound at the casing split and bearing housing cover to ensure no leaks occur. Additionally, it's recommended to double-check alignment and various tolerances throughout the assembly process. Please remember to refer to the manufacturer's documentation for detailed instructions specific to the turbine model. Thank you to watch this steam turbine overhauling last episode. For more information about steam turbine, please watch my video Steam Turbine on my channel. If you like my video, please like and share it, subscribe and follow my channel. For technical video, please see my playlist.